Hello everyone. In this video we will see concept of rotation in complex algebra. Okay. So first of all you should remember that in organ plane this is your real axis, this is your imaginary axis, and this is your complex number. So every complex number is represented by a vector. So this vector OP is represented by the complex number Z. Okay. Every complex number represented by a vector. So vector here O is initial point, P is terminal point, and definitely the modulus of this vector OP is given by modulus of Z. Correct? Fine. And Z can be represented, complex number Z can be represented in three ways. We know that. It is Z is equal to x plus iota y Cartesian form, and Z equal to R into cos theta plus I sin theta polar form, and Z is equal to R into e की power iota theta in Euler form, where theta is principal argument. Theta is principal argument of Z, principal value of argument of Z. The principal value of argument of Z is always lying between minus pi to pi, including pi. So this Euler form of complex number, this form, Z equal to R into E iota theta. R means where R is modulus of Z. Modulus of Z is R. So this form we will use over here in the concept of rotation of complex number. Correct? This form we will use. Okay, fine. This is okay. So we will represent this complex number Z. See, if this is, say, theta 1 is its argument, okay, and modulus of Z is R. R only simply modulus of Z. So I can write Z equal to modulus of Z into e की power iota theta 1. Okay, Euler form, I can write this complex number Z like that. And if suppose that I am rotating this complex number anti-clockwise with the theta degree. So this is the new position. Okay. So we are getting now new Z. The new position of Z is Z1, and this position is obtained after rotating this OP vector theta degree anti-clockwise direction. So I can write down Z1 equal to modulus of Z1 into e की power, and the argument is theta 1 plus theta. Theta 1 plus theta. And if the modulus of Z1 and modulus of Z are same, so I can write down this Z1 equal to modulus of Z into iota theta 1 into iota theta. Okay. Now, modulus of Z into e iota theta 1 is your this Z. So Z1 is Z into e iota theta. This is all about the concept of rotation of complex number. Now you have to understand this, read out this, interpret this properly. See, we are multiplying Z with e की power iota theta to get Z1. Here you are rotating Z theta degree anti-clockwise to get the new position as a Z1. So your e iota theta is your multiplication, is a factor, rotation factor. Rotation factor. So when you are multiplying any complex number by e की power iota theta, that means your complex number is being rotated anti-clockwise theta degree. See, from here I can also write down Z1 by e iota theta, that is equal to Z. Correct? This e iota theta I can write as e की power minus iota theta, that is equal to Z. Now look at here, Z1 is multiplied by e की power minus iota theta. So we are getting Z. That means when a complex number is rotated clockwise direction, correct? So when theta is positive, anti-clockwise rotation, when theta is negative, clockwise rotation, correct? And here we are rotating the complex number, okay, simply rotating. That is the modulus of this vector and modulus of this vector is same, correct? And one more thing we can write down, see, z1 equal to z e की power iota theta, z1 equal to z e की power iota theta. I can write out z1 by z equal to e की power iota theta, same thing. Now z1 can be written as z1 minus 0 upon z minus 0 e की power iota theta. Now look at here, z1 minus 0 represent a vector which is a final vector, correct? This is your final vector and this represent your initial vector. See, z minus 0. So when z minus 0 means initial vector and z1 minus 0 is your final vector. So z1 minus 0 upon z minus 0 equal to e iota theta. That means this initial vector z minus 0 by complex number, this vector is OP represented by z minus 0, that is the initial vector, is rotated anti-clockwise direction theta degree to get the final vector z1 minus 0. Got it? And if suppose that here the initial point of the vector is origin, so we are rotating the complex number about the origin. But if we are having like that, what is that? This is something like that, z0 and z1. So this vector is given by z1 minus z0, correct? This vector is z1 minus z0. This is your initial vector and this is rotated, okay, anti-clockwise direction theta degree. So this vector is your z2 minus z0. So by the concept of the rotation of complex number, I can write z2 minus z0 upon z1 minus z0 e की power iota theta. Mind it, here the modulus of both the vectors is same. Because this z1 minus z0, this vector can be written as z1 minus z0 ka mod into some argument, whatever be the argument it is making with the positive direction of x-axis, this argument, correct? But the modulus are same, na? Therefore we can directly write down. If modulus are not same, means z2 minus z0 can be written as modulus of z2 minus z0 into its argument e की power iota something argument. Similarly, z1 minus z0 can be written as modulus of z1 minus z0 into e की power the argument iota theta, something like that. Now, I can directly write down this form as a, how we can write down? I can write down like that. See, z2 minus z0 divided by z2 minus z0 ka mod, that becomes the unit vector, okay, along this vector, and z1 minus z0 divided by z1 minus z0 ka mod, that becomes the unit vector along this vector into ka e iota theta, So that is the case, correct? So when the modulus of these two vectors are not same, then we will rotate the unit vector along this vector to get the unit vector along this vector, correct? Or you can say that z2 minus z0 upon z1 minus z0 equal to modulus of z2 minus z0 upon modulus of z1 minus z0 into e की power iota theta, correct? Same thing. Same concept we are describing in different ways. If both are same, the modulus of both the vectors are same, this is e की power iota theta only, that is this form. Correct? If modulus are not same, then we can write in that way. Is that clear? This is simple. Similarly, here also, here we are having the same modulus, therefore I can write z1 equal to z into e iota theta. Correct? Otherwise, I can write down here also modulus of z1 divided by modulus of z like that. So this is all about the concept of rotation of complex number. What we learn mainly two things, that we are rotating the complex number about the origin, or we are rotating the complex number about fixed complex number, something like that, z naught. Second thing, we are simply rotating the complex number, not stretching, not compressing. That is, the initial vector and final vector modulus is same. Third thing, we learned that when we are rotating anti-clockwise, okay, that is if theta is positive, then we are rotating the complex number anti-clockwise, and if theta is negative, then we are rotating the complex number clockwise. That is the thing. Correct? There are also some important results, special cases we will see here. Some special cases. If z and e की power iota theta is your rotating factor, e की power iota theta is positive, rotation is anti-clockwise direction, and if theta is negative, rotation is clockwise direction. So when z is multiplied by e की power iota pi by 2, that means that the meaning we can understand, z is being rotated. This we can understand, z is being rotated theta degree anti-clockwise. Theta degree anti-clockwise about the origin. About the origin. Correct? This we understand. Now what is the new position after rotation? So you know that e की power iota x is cos x plus iota का sin x. That we all know. Correct? So therefore e की power pi by 2 will be cos pi by 2, that is 0. Sin pi by 2, that is 1, that is simply iota. So the new position, so z into e की power iota pi by 2 gives iota z. So iota z is your new position after rotating z. Pi by 2 means 90 degree anti-clockwise about the origin. Got it? So that means this is something like that, no? This is something like that. This is something like that. The angle between z and iota z. This is z and this is your iota z. The angle between them is 90 degree. Angle between z and iota z is 90 degree. So automatically, second thing clears. What is the second thing? When z is multiplied by e की power minus iota pi by 2. So definitely you will get minus iota z. Minus iota z, because here the rotation is clockwise. Rotation is clockwise. Clockwise 90 degree about origin. Correct? Rotation is clockwise 90 degree about origin, and z becomes minus iota z. Or you can say that this is something like that. Z, this is minus iota z. Correct? And this angle is 90 degree in the origin plane. So angle between z and iota z, and angle between z and minus iota z is 90 degree. Or you can say that e की power iota pi by 2 is a rotating factor, that it can rotate the complex number. When we multiplied any complex number z with the e की power iota pi by 2, that means the complex number is being rotated 90 degree clockwise when pi by 2 only. When minus pi by 2, then it is rotated clockwise. That is, first one is anti-clockwise, pi by 2 positive, then anti-clockwise rotation. and pi by 2 negative, then clockwise rotation. Got it? Or you can say that the angle between z and iota z is 90 degree. The angle between z and minus iota z is this concept is very important. Okay. Third one is look at here. When z is multiplied by iota pi. Okay, then what is its new position? So any complex number is multiplied by e power iota pi, that means it is being rotated. Pi is positive, that is it is being rotated anti-clockwise direction 180 degree about the origin. So the new position we can find out. Now e power iota pi here, iota pi is cos pi plus iota sin pi. Sin pi is 0, cos pi is minus 1. So therefore there is simply z into minus 1, that is minus z. So your complex number is being rotated. Okay, this is your z, then this is your minus z. Got it? This is 180 degree anti-clockwise direction rotation. You understand this? Similarly, we can rotate the complex number by 120 degree anti-clockwise direction or clockwise direction. See, what is the new position? Fourth one is z is multiplied by e iota 2 pi by 3. So e iota 2 pi by 3, 2 pi by 3 is positive. Therefore, 120 degree anti-clockwise rotation of this complex number z about the origin. So e iota 2 pi by 3 means cos 2 pi by 3 plus iota sin 2 pi by 3. This is cos pi minus pi by 3 plus iota sin pi minus pi by 3. Second quadrant cos is negative, that is minus cos pi by 3 plus sin is positive pi by 3. Cos pi by 3. Cos pi by 3 is how much? 1 by 2. Sin pi by 3 is how much? Root 3 by 2. Correct? So minus 1 by 2 plus iota root 3 by 2 is your definitely omega. So therefore this is z omega. So new position of z is z omega. Correct? So when we rotate the complex number, now you have to understand, okay, geometrically, that interpretation you should also know that when we multiplied any complex number by e की power I 2 pi by 3, that means the complex number is being rotated 120 degree anti-clockwise direction and the new portion is z omega. Similarly, when z is multiplied by e की power minus iota 2 pi by 3, the new portion is minus z ka omega, because here we will get minus omega, and that means the complex number z is being rotated 120 degree clockwise direction and the new portion is minus z ka w. Correct? Okay, fine. So this concept we understand. Now let's see the two important concept, two important application about the rotation of complex number. What is the first? The area of triangle formed by A, Z, B, I, Z vertices are given in terms of the complex number Z plus I, Z. This is the first one. This is very important application of concept of rotation. See A, this is Z. See B, this is I, Z. And this is C, Z plus iota Z. We have to find out the area bounded by this triangle. Now we can apply the concept of rotation. See, if I say that this is a vector, okay, that means this vector is represented by, the length of this vector is represented by modulus of difference of this two complex number, and that is z plus iota z, that is simply modulus of z. Correct? And this vector length is given by the modulus of difference of these two, z plus iota z, z, okay, modulus positive negative, that is always positive. So here we are having modulus of iz. So see, this is the vector represented by z. The length is given by modulus of z. This is the vector represented by iota z. The length is given by modulus of z. So we know that z and iota z vectors, the angle between them is 90 degree. The angle between them is 90 degree, correct? Okay, the angle between them is 90 degree. See, now in the triangle direction is not important. See, when z is rotated 90 degree anti-clockwise direction, we get iota z. Or if z is rotated 90 degree clockwise direction, then we get minus iota z, whatever way it is. But the angle between z and iota z or z and minus iota z is 90 degree. So therefore this angle is 90 degree, and the length of these two is modulus of z, and modulus of iota z is modulus of iota into modulus of z. Modulus of iota is always 1, so this is simply modulus of z also. So therefore area is half into base, that is modulus of z into modulus of z, and that is equal to half modulus of z square. Got it? Got it? Good. Because this vector and this vector we can find out by the modulus of difference of these two. Correct? Difference of these two. That okay? Fine. Okay. Second concept we will see now. The second application of concept of rotation of complex number. Here. See. In equilateral triangle, okay, this is A, Z1, this is B, Z2, this is C, Z3, ABC is an equilateral triangle. Okay, equilateral triangle. So therefore, their length are same. Okay, these length are same, and angle between them is 60 degree. So if suppose that this vector is rotated in that way, okay, so this angle will be given 60 degree, and the modulus of these two vectors are same. So this vector can be written as, this is initial, this is your final. We are going from here to here. So this is your final. Final is Z3 minus Z1. Initial is what? Initial is Z2 minus Z1. And that is equal to E iota 60 degree. Equation number 1. Suppose I am rotating this to this one. So this vector is rotated now in this direction. Anti-clockwise direction, no problem. But this is final. This is your final. Final is this one. Okay, Z1 minus Z2. So Z1 minus Z2. Initial is your Z3 minus Z2. And that is equal to E iota 60 degree. So therefore, I can write down Z3 minus Z1 upon Z2 minus Z1 equal to Z1 minus Z2, Z3 minus Z2. Then you will get the important relation, that is, this will give, the simplification of this will give Z1 square plus Z2 square plus Z3 square equal to Z1 Z2 plus Z2 Z3 plus Z1 Z3. So this is the condition. This is the condition that A Z1, B Z2, C Z3 represent an equilateral triangle. An equilateral triangle. So we have seen the two important application of rotation of complex number. This is the vertices of a triangle A, B and C represented by Z1 and Z2 and Z3. This triangle is an equilateral triangle if this condition hold. Z1 square plus Z2 square plus Z3 square equal to Z1 Z2 plus Z2 Z3 plus Z1 Z3, and that condition we have obtained by using the concept of rotation of complex number. Correct? Earlier we have seen the area of the triangle formed by the vertices AZ plus B iota Z plus C Z plus iota Z is a right angle triangle, and the area is given by half of modulus of Z ka square. So these are the two important results we have seen. We have understand the rotation of complex number properly. That is, the e ki power iota theta is your the main factor to rotate any complex number. If we multiply the complex number z by e iota theta, That means the complex number z is being rotated theta degree anti-clockwise if theta is positive, clockwise direction if theta is negative. Got it?